Continuity, that's the section here. So let's start with this picture graph here. If you can draw a graph without lifting your pen, then that graph is called continuous. So here you can draw this without lifting your pen. For this picture here, as you can see, when I try to draw the picture, I have to lift. So here you see the jump, here you see hole, and there is a jump down, jump up, jump down. So this is not continuous. This graph is not continuous at 1, 2, and 4. The previous one was continuous. There was no jumps, no hole. So that's the continuous function, a continuous graph. But there's supposed to be formal definition of continuity. How do you define a function is continuous? So if you have a function, and if you want to check if either that function is continuous or not at some specific point, then the limit of that function should exist when x approaches to c, and that limit is supposed to be equal to the value of the function at c. So if you go back to the previous picture here, you see the limit of this function when x approaches to 2 is 1, because it's going to approach towards 1 from left side and right side. But because the value of the function at 2 is different than the limit of the function, this is not continuous at 2. Okay, so a function supposed to be continuous. If the function is continuous if the limit of the function when x approaches to c is equal to the value of the function at that point c. Sometimes what happens is you just have continuity from one side only. And let's say you have a graph and then function is continuous when you approach to c from right side. You can see the limit of that function and that is equal to the value of the function. Then that's called right continuous at c, and this is left continuous at c. So this left and right, it's only depends on, do you have the limit of the function when x approaches to c from one side only? Then, and that limit is equal to the value of the function, then that's a continuous from one side. Example, in this graph, as you can see, the limit of the function when x approaches to a, that is only possible from right side because there is nothing on the left side. So this graph is continuous from right side at a. This graph is continuous from left side at b because there is nothing after b. And anywhere in between a and b, this graph is continuous from two-sided. That's called continuous function. So how do you check either your function is continuous or not at some specific point? So these are the three things you can check. First of all, make sure that the value of the function at that specific point uh, that's defined, there is a value. And number two, find the limit of that function. And number three, check number one and number two, either they are same or not. If they are same, then the function is continuous at that point C. This is a continuity test. Some of the properties of the continuous function, let's assume that you have two function f and g and both of them are continuous at c. Then there's some difference, multiplication of one of the function by some constant, product of two function, all of them are continuous at that point. The division, the power of continuous function with a positive integer is also continuous. And the root, nth root of continuous function, if n is positive, is also continuous. If you try to combine two functions using the composition, that new function, whatever you get after composition, that's supposed to be also continuous at that point. This is the graph you can look at to understand the concept. You have the function f of c, and this function is continued at c, and you take z of that function, and that is also continuous at f of c. So the final product, which is the composition of g and f, that is continuous at c. when you try to find the limit of continuous function, it's very, very useful because you can switch, you can find the limit of inner function, and that will be again the same value. You see here, both of these function are, g is continuous function, and you know the limit of the function f of x is b, then because it's a continuous, you can bring this limit inside and find the limit of inner function, which is b, and you can find the value of the function or the limit of the continuous function. I'm going to use these properties or these theorems, these rules, while doing the problems, okay? Intermediate value theorem. Let's say f is a continuous function that is defined from a to b. A function means the value is supposed to be on the y-axis. As you can see here, it's going from f of a to f of b. So if it's a continuous function, then no matter what point you pick from f of a to f of b, there's supposed to be the value on x-axis for the function for that particular value. And this is called intermediate value theorem. You're going to get a point on x-axis from a to b in a way that the value of the function at that point would be here. Okay, let's look at some examples. Question number 1. This is the graph you have given, and you just have to state whether the function graph is continuous on -2 comma 7. When you look at the graph here, you see there is a hole at +1, so this is not continuous at +1. So the graph is not continuous at +1 because the limit exists, but the function is not defined at that point. So if you focus here, you can find the limit of this function. From left side and right side, it's going towards the same value, but the function is undefined. So this is the answer. Let's go to the next problem. At what points is the given function continuous? This function is a rational function, and a rational function is continuous everywhere in its domain. So you need to just find the domain of this function. At x equal to 1, the function is undefined. So the domain of the function is all the real number except 1. So the continuity also, this function is continuous everywhere except 1. So how do you write that in the interval notation? You just have to use parentheses. So except 1, so you go from extreme left, this is your, this function is continuous everywhere except +1, because at 1 the function is undefined, there is a hole there. So how do you write down everything else except 1? You start from -infinity, you go up to +1, you do not include 1, take union, and you go right side to the 1. So this is how you write in interval notation. So that would be -infinity, comma +1, and then comma 1 comma +infinity. So we are including everything except +1. Let's go to next problem. At what points is the following function continuous? This is a trigonometric function, and then also you can see there is a quotient. So you have to keep in mind when you deal with this type of function, you try to find out the domain, or you try to find out where this function is undefined. So on the denominator side, square of any number is either 0 or positive. So there is no value of x which makes the denominator 0. So you don't have to worry about this denominator. So the only worry or only point you have to pay attention here is the domain of 10x. So as we know, 10x means it's a sine x over cosine x. So this function would be undefined wherever the cosine function would be 0. Here it's not x, it's a 2x. So we know the cosine function would be 0 when you have at pi over 2, or the or multiplication of pi over 2, like pi over 2, 3 pi over 2, 5 pi over 2. At those values, cosine function is 0. But here it's a 2x. So 2x cannot be equal to this value, where n is odd integer. So don't forget about that, okay? So when you try to solve this, x would be n times pi over 4. So this function, this tan 2x is undefined at these values, where n is odd integer. So what you can say? You can say, hey, this function is continuous everywhere except when x is n times pi over 4, where n being an odd integer. Okay, one last question. How can you define or rewrite this, define this function such that this function is continuous at 8? So keep in mind, continuity means the the limit of the function and then value of the function is supposed to be same. If you look at here, this function, and if you try to simplify, at when s is equal to 8, the denominator will be 0. So it's undefined at 8 at the moment. So if you simplify on the top, because that is a cubic, so that would be s minus 8 times s squared plus 8 times s, 8s plus 8 squared, which is 64. These are the two factors of the top part. If you are, if you need, some help, then just pause the video and try to find the factors of this cubic polynomial. And then on the bottom part, because it's s squared minus 64, these are the factors, s minus 8 and s plus 8. One more time, if you need some time to understand this factoring thing, then pause the video and check how to find the factoring of this type of polynomial. So after that, this is gone, s minus 8, s minus 8 is gone. At the moment, at the beginning, the function was undefined when s is equal to 8. Now this function is, if you try to find the limit of this function when s approaches to 8, sorry, not infinity, 8, you just have to plug the value of s at as 8. So that would be 80 squared plus 8 times 8 plus 64 divided by 8 plus 8, which is 16. So that is actually 64 plus 64 plus 64, which is 3 times 64. And this is 2 times 8. So if you just simplify this, it would be 12. After just simplification, the limit of the function when s approaches to 8 is 12. So if you want to make this function continuous, then the value of the function at 8 is supposed to be 12, otherwise it's not possible. So the only way we can make this function continuous by redefining the function at 8, and that's supposed to be 12.